All right, so now we have a line, so this should remind us of example 1. We have a line with density given by the function 12 over x plus 4. So this is like our density function, and I don't care if you remember this, but a lot of times density you'll get this symbol. This guy is a lowercase delta, right? So that's a little delta. We use big delta for change. Little delta gets more than one use, but one of them is for density functions. I think I've seen rho used as well. I don't care. You call it whatever you like. Okay, so the density varies. And x here is how far we are from the front of the line. So let's say this is the front and this is the back. And x tells us how far we are along the line. So if we investigate a little bit, for example, when x equals 0, we're right at the front of the line. And the density at the very front of the line is supposed to be 12 over 4, so 3 people per yard. If we are 2 yards from the front of the line, then we get 12 over 6, which is 2 people per yard. If we're, what's another nice one? 8 yards from the front of the line is a really easy one. We get 12 over 12. We have 1 person per yard. So the line is getting less dense as we work our way back. So people are more tightly packed at the front of the line, and it gets a little more spread out as we work our way back. We want, same idea as before, we want to say if the entire line is 8 yards long, how many people are in the line? And granted, people are a very discrete thing. This is not like a continuous, we have people like all blurred together. But still, it's a good example to get us going. So our tricky issue here is that the density is not uniform. So what does Calc 2 tell us to do? It tells us to make a little slice, and on that little slice, we're going to assume that the density is uniform. The idea being that's not exactly true, but if we make our slice infinitely skinny, it will become true. So I am x yards back from the front of the line. I'm going to make a little slice that's delta x yards long. And I want to figure out how many people are in this little slice of the line. So I know that the length of the segment I'm talking about is delta x. So let's call this x sub I for a specific. On this section of the line, the density is 12 over x sub I plus 4. So if we want to figure out the total number of people in that little tiny slice of line, so I'm going to call this p sub I, we would take the density, 12 over x sub I plus 4 people per yard, and we would multiply it by the length of the line in yards. What some people want to do, people per yards times yards. What some people want to do is multiply by x, but that doesn't work because if we take the entire first x yards of the line, we definitely can't assume uniform density. That's why we have to look only at a tiny little piece at a time. And so for the next one, we'd move over to the next x sub I and we'd get our best estimate on that little interval. If we want to add up all of the people, we're going to do that with an integral. We're going to be integrating the 12 over x plus 4 dx. And we want to start at the front of the line. Since x is distance from the front of the line, that would be x equals 0. We want to stop at the back of the line, which is 8 yards. So again, this can get a little trickier, but this is the kind of thing we'll want to do. If we don't have uniform density, we want to make a slice so that everything on the slice is basically uniform density. So let's see, that's a x to the first power in the bottom. So this is going to be a natural log. You want to think really carefully about if you have a chain rule to worry about, but we don't here. The derivative of x plus 4 is 1. So we're going to go from 0 to 8. I guess I don't need approximately yet, which equals 12 times the natural log of 12 minus 12 times the natural log of 4. We can combine them if we want, not that you have to, but just to save me, I don't need a parenthesis yet, from typing more into my calculator. So basically you can factor the 12 out. And then log properties say you can make that into a single fraction, 12 over 4, which let me go ahead and simplify as I'm at it. So we need 12 times the natural log of 3. Let me see where I set my calculator. Don't mind me. Okay. So 12 natural log 3 is about 13.18. So to answer the question, I would say there's about 13 people in this line. All right, thanks for watching.